¿Qué tal? Muy buenos días a todos. Mi nombre es Miguel Mánica y hoy tengo el honor de moderar esta sesión que forma parte del ciclo de conferencias técnicas Verano 2024. Esta iniciativa de Amitos reúne a nuestros socios empresariales para presentarnos diversas herramientas, desarrollos y avances significativos en el campo de la ingeniería de túneles y obras subterráneas. El día de hoy contamos con una conferencia por parte de nuestro socio empresarial Dolenco Tunnel Systems, titulada Optimizing Tunnel Design with Innovative Drainage Solutions, que será impartida por Johnny Poulsen. Y me voy a permitir leer una breve semblanza de nuestro ponente, pero antes de hacer eso, me gustaría dar unas breves indicaciones. La conferencia va a ser en inglés, pero tenemos el servicio de traducción simultánea. Eso lo pueden encontrar en la parte inferior de su ventana de herramientas de Zoom. Ahí hay un símbolo que es como si fuera un pequeño mundo. Ahí pueden encontrar la opción de escuchar la presentación en inglés o en español. También al final de la sesión, de la presentación, habrá una sesión de preguntas y respuestas. Entonces, a medida que vaya progresando la presentación, pueden ir haciendo sus preguntas en el chat, ya sea en el chat convencional o en el chat de preguntas y respuestas. Nosotros vamos a monitorear ambos y al final tendremos esa sesión de preguntas. Entonces, pues sin más instrucciones, pasaremos ya al inglés y leeré una breve semblanza de nuestro ponente. So, again, welcome everybody. We have this amazing talk by Johnny Poulsen, titled Optimizing Tunnel Design with Innovative Drainage Solution. And before giving the floor to our speaker, I'm going to read a very brief CV summary. So Johnny Poulsen is the CEO of Dolenco Tunnel Systems, with over 25 years of experience leading this business based in Denmark and abroad. He has gained vast experience in identifying and selecting waterproof and concrete repair solutions. By distributing and subcontracting a wide range of specialized solutions, Johnny Poulsen has accumulated know-how and expertise on tunnel and underground structures on the global market and international forums. With his experience, he has begun leading the development of new innovative solutions to accommodate the changing needs in underground construction and continues to develop and adapt to the increasing changing condition of construction in the world. Johnny Poulsen, thank you very much for being here and to deliver this very interesting lecture, and the floor is yours.
Thank you. And thank you, Miguel, for the introduction. And thank you, Juan, for the invitation to come here today. As you mentioned, I'll make a presentation. And without saying something now, I would like to just switch to the presentation and we'll follow this. And there'll be a few segments there, some introduction to the tunneling, then a little bit about the basis of the tunneling system that we have done, the drainage system, and there will be some specifications about the product, some specifications about projects, how to do, and then finally some technical drawings as well. And at the end, there will be a possibility to ask questions, of course. If there is something during the webinar that you have questions you think is relevant, and just go in and ask them during the way, and we can certainly handle that on the way as well. So without further, then I will just give me a second. I'm going to share the screen. Okay. So welcome. Today we'll talk about what we're seeing here, the problems of constructing a tunnel. And as you can see here, this is typically the NATM method with shotcretes, which is what we're talking about mostly today. When we start up and talk about tunneling, we have two things we typically think about. That is the soil and the water. And when we do the excavations, we could talk about the soil dynamics. What happens when we dig out an entire tunnel from a mountain? The soil dynamics change, and they can change dramatically, as we can see on the picture here. And of course, our work is complicated because these changes are very variable. We don't always know. We try to make investigations, but still we get surprises during the phases we go through. So now what we have is the pressures from this open excavation we have made. We have pressure from water and soil. And typically for the water, we see that being the pressure being released into the tunnel. And this is how we see all the water running in, of course. So we conclude that we do the construction the best we learn. And we do this, of course, to make it useful. In the beginning, to make it safe, but useful, so we can utilize it for whatever the aim of the tunnel is. Then after we have constructed the whole linings and so on, what we have decided for the individual project, we will get a new dynamic and a new balance in the structure. And this is kind of the basis for the soil dynamics. We see that it's settling and it's finding a new balance there. As for the water, we have the same cycles where we excavate, the water starts flowing just freely in wherever it is possible. And we can see this on the photo here. You all know about these situations. And during construction, we have to do different things to accommodate these problems that we see during construction in different ways. And the water affects the different steps of construction. Also, after we have done the entire construction, we have a new phase with other kinds of problems. With the typically, what you see is that when you have the lining installed, you have a number of issues coming from the increasing pressure of water accumulating behind the new lining that has made the stabilization there. So we find a new balance with typically with more pressure on the structure after some time. And this is also the cause of some of the problems that we see during the maintenance and the utilizing of the tunnel over many years. And we see a lot of remedial work and so on during time. So this is a little bit about the soil and the water conditions that we are facing. So you can see, why is this a problem? What is the specifics of this of the problem with the water pressure here? Well, of course, when we start constructing, it's about the safety in the tunnel, that we can actually get in and we can start working. We typically see we have a lot of repair works that has to be done, and that delays the process of constructing. If we haven't had the proper installing over time of solutions that will be durable over a long time, we can also have structural integrity over time. And we saw this in one of the first pictures where it simply collapses. That's the risk. So furthermore, when we have cracks and so on, water coming in, we have a problem with the moisture in the air and the seeping water. It will damage the installations often, and we have to replace them, which is costly. We can have failures that are also critical in the installations. Further, we have the drippings on the roads, on the tracks, and on the installations. The further of the structural part is, of course, the cracking from the frost. If you have frost in the cracks and the spalling and so on, and parts falling down, ice falling on the different situations. We have from the water the ice formation on the surfaces in the tunnel, on the ground surface where you have the rail or the roads, and of course, all these, they can make it very costly to maintain the structure over the lifetime, the LCC life cycle of the structure. So there's a number of issues with this water pressure. So what do we do? What do we try to do? We try to do three things. We try to block it by grouting or waterproofing, similar. We try to divert the water by line drains and other drains, and this is what we're going to talk about later. We try to accept it. We simply say that it drips a little bit. That's okay. We'll have to do something over time, and it's not critical. And then long term, we have to go and do some remedial work, injection, concrete repairs, replacing installations, and so on. So this is basically what we're doing. So there's no golden solution to building tunnels, as we know. It's very, very complicated. So during the construction, we have excavated until we are finished and ready to use the structure. We have some components, the shotcrete, the concrete, where we can do some things. We can make it a fast-setting product. We can design for the crack width. We can also cast heavy linings, and there's other issues as well that we can do. We can stabilize. We look at the stabilization, maybe with steel girders, with anchors, wire meshes, and so on. And we're trying to do some drainage, line drain, dipple sheets, geotextiles. And then finally, the waterproofing. The primary grouting. You can use membranes, spray membranes, sheet membranes. You can add fibers, or you can inject during construction. So we have a number of tools during construction. The thing is that we have not really any systematic approach. That's what we kind of looked into with our more than 25 years of experience with waterproofing. We looked at what can we do? What do we need to try and alleviate these problems? And the basic thing we found was that how do we manage the water pressure in a systematic way? So this is why we developed the systematic drainage design approach. And by doing this, we wanted to first avoid blocking the water, because it's highly problematic, especially over time. We don't accept the seeping, and we wanted to reduce the long-term repair. And we had the philosophy that when we did this, it should be some way of permanently preventing water pressure. So with this in the baggage, we developed the Dolenko drain system. And you just saw the video here in the beginning. And to elaborate further on this, I would like to just go through this image here a little bit first. And as you see, you have the base rock, and then you apply the safety layer of shotcrete. And at this point, we would like to add the Dolenko drain on the surface to receive the water as early as possible in the structure. In this way, it alleviates the pressure on the inner lining, and then alleviates a lot of these problems and issues that we described here in the previous slides. So what is a Dolenko drain, the product? Well, first of all, it's half pipes in a mesh that is interconnected horizontally and vertically. What you see here on the right is actually the product, the way it looks. And it is only 14 millimeters high, so it takes very little space to install it in the structure. It is 1 square meter per module, and it weighs only 660 grams, so it's very easy to handle. As you can see on the picture on the left bottom, it illustrates very well the dimensions and the embedded strings in the concrete. And then there is, of course, a number of nailing points on the module. And as you can see here, this is how they are connected. We start with the modules from the top, and then we overlap them vertically. As you see the top left picture, you overlap the ends so the water can be directed further down to the base of the tunnel. And besides that, on the bottom left, you can also see the horizontal connections. So the water can go from one string to the next. And this is very important that the water can go horizontally as well. So it can alleviate any kind of pressure, or if there is quite a lot of water, then you will have the water dispersing sideways as well. So there is no pressure built up in the strings. Now, the first step is that we start from the top, and we mount the first modules and overlap them down on one side in one line, and then down on the other side, overlapping and going to the base where there is a detail for alleviating the water, so the water will be led away from the structure. And then, of course, the inner layers, which can be shotcrete with fibers, it can be with crystalline waterproofing, it can be with a spray membrane, it can be combined with a sheet membrane, and it can also be done without any other features if you have a thicker layer of shotcrete, and depending on the volume and the pressure of the water coming out of the structure. So at the base, we see the water coming out. If for some reason one of the strings would block, as I mentioned before, the water will disperse sideways to the next strings and the next strings and alleviate the pressure. However, if the client has a need for investigating, are there a lot of blockages in the strings, then we have also in our patents, we have included a scanning method where you can actually identify the blockages in the strings by investigating and seeing if there is water in the string or if it is empty. And when we have found the blockage, we can go in and either route it out mechanically or by water pressure, so we can clean the strings if necessary. It's not something that we see very often is an issue because of the nature of the mesh when there's so many strings that are interconnected. And then we can check at the bottom if the water is coming out of the strings to see if it's fully in function. So a little bit about the capacities of Dolenko Drain. When it is installed, it can take 8 cubic meter water per linear meter wall per hour. And the volume is, of course, quite significant. So we really don't see a need for more than that. And if you have this kind of water, you probably cannot get the shotcrete to stick to the surface anyway. So you'd have to do some grouting or other or leading it away in a hose or similar different ways of doing this. And since it is embedded into the concrete, it will be a permanent solution. So it will last in the lifetime of the structure. Dolenko Drain is made of partly recycled material, and it can be also recycled 100% after if it has been decommissioned, the tunnel, or you need to repair. You can take out the modules, you can completely 100% reuse them. That's the material we have chosen to use for the production of the product. So as you can see here on the photo, this is actually from the project we have ongoing now in Toyo in Colombia, where it is being applied over where shotcrete has been applied over Dolenko Drain, and really without any spray membrane And there was a lot of water coming in certain segments, and we recommend to use 2 layer of shotcrete over the drain, so that the first one just takes most of the water if there's a lot of water flow, and then the second layer will stop the rest. Or you can do some remedial work with plugging and so on during the process. As you can see here in this tunnel as well, you can see it creates it needs very little space to be installed again, because you need like 50 to 80 millimeter shotcrete over the drains, over the modules. So you can make very slim structures. Especially this is relevant if you have a rail tunnel where you typically don't have too much extra space to work with. So it can be used, as we see, in tunnels, but also we have also other application areas. And this could be second piles, which we see often it could be in stations, railway stations, it could be on slopes, retaining walls, it could be in shafts, and so on. And of course, the drain can be used both for repair and in new tunnels. Often when you talk about repairing, there's limited possibilities to what to do in terms of installing new materials and so on. And here's again an advantage of putting the drain in, so you permanently prevent the pressure on the inner lining. So one of the other advantages of permanently preventing the water pressure is that if you use a spray membrane during construction, you will be able to keep the water pressure away from the spray membrane as it is hardening. It needs time to harden before the water comes, and this is very often an issue since the water is seeping through or making the concrete moist. It can also be because you have damages on the membrane. Maybe you need to do some repair of the membrane because water comes through, and all this you can save time and money on by having the drain behind that. So of course, minimizing injection is not only during construction, it's also during the lifetime of the structure, because you permanently have relieved the pressure from the inner lining. Closing down the tunnel is not a cheap and short time solution. It takes time and it's costly. So if we can just save a little bit of this, then it's a very, very important saving to do. Now, the drain is, as I mentioned in the beginning, it's very lightweight, and it doesn't take much space. So you can basically, when you mount the drain, what you can have a scissor lift, and you can have 2 persons, and a nail gun with battery, a pallet of the product, and then you can go into the tunnel, immediately start working, and get out of the tunnel just before the time frame is up. So if you have little time to do repairs, this is a very, very easy solution to work with. So when you have the strings installed, another feature is that you have the concrete before and after the drain. There's very good adhesion between those two. And that creates a monolithic structure. So we have about 70%, or actually exactly 70% of the surface has adhesion of the 2 concretes. And in this way, we can create a structure now like a monolithic structure. So both the primary and secondary lining are permanent linings. With that in mind, then sometimes you as designer, you can even calculate in maybe reducing the inner lining concrete layer. So often you will be able to save on the concrete as well. This is, of course, very interesting in terms of direct cost, time savings, and even CO2 savings in structures. And the picture here is from a ramp where it was second piles leveled out and the Dolenko drain mounted onto that, covered with shotcrete, a spray membrane, and another shotcrete layer. So talking a little bit more about the advantages, we talked about the CO2 footprint. We have done some calculations that show that there's a significant savings, and we just talked about why. We tried to do this in both in hard rock situations and in soft rock situations. In terms of the direct cost, we also see quite a lot of cost savings, and this is for the procedure of the construction. It's about how much materials you use and the speed of the work also saves cost. As is on the right here, this is a project from Spain, where they actually built a scaffold around the rail, so the train is actually running during work, and of course this made it possible to work faster. And construction time, that was the most surprising for us in our calculations. We saw that there was actually a high degree of time saving in using the methods with Dolenko drain in the structure. On the right, this is a photo from also a project in Spain where it has been combined with a spray membrane. It's a very thin layer of shotcrete over Dolenko drain, which normally we normally see more than this, but it worked well anyway. So before going further, I would like to show you a small video about second pile applications, as you can see on the picture here. Just give me a second here. Here we see the leveling out between the piles and repairing the reinforcement. Mounting of the Dolenko drain. Two persons and a nail gun, and two persons can mount between 12 and 20 square meter per hour. In this case, they cover with shotcrete, and that's it, 50 to 80 millimeter. And also in this structure, they also use the floor version we have, which is for water coming up from underneath. This can be used for inverts as well. And this is, of course, load bearing. Good. So that was a little bit about the second piles. Besides this, we have a number of other application areas. It could be, for example, on the rock before shotcreting in an open gripper TBM, and it could be on slopes between two layers of shotcrete. About applying Dolenko drain directly onto rock. Let me just jump a little bit here. This is the installation details for the rock from the video. I'm not going to go too much into this since we're talking about tunnels. So here, directly onto rock. Usually we mount the linker drain onto minimum 30 millimeter of shotcrete. And this is because the nails we use are 30 millimeters. And but we have had requests, and there's been done some projects where they have put the linker drain directly onto the rock. And this was a request because they could not get the shotcrete to stick to the surface. So they basically just held the linker drain onto the surface with the unevenness that there is on the surface of the rock, put a wire mesh over, as you see on the picture here on the right, and fix it with anchors, and then shotcrete the whole thing. And actually what happened was that they could get the shotcrete to stick to the surface, and they stopped 80% of the water flow. So in that way, it was a very pragmatic solution and successful in their eyes, because there was it was making it possible to do something that you otherwise would not have been able to do. The lining was finalized with by casting. That was the only thing they had in the project. They had casting of concrete on the inside. And by doing that, they stopped the water 100%. And when you think about, now we went through a little bit about the linker drain. What happened is that when you put the concrete on the inside there, the water will not try and go out through the first shotcrete layer anymore. It will just go back into the string and the mesh, which is behind the shotcrete, close to the rock, and in that way alleviate the water pressure into the wire, into the linker drain net. So this way it shows you how the linker drain changes the dynamics of the structure. So it permanently prevents the water from pressuring on the inner lining. And that again is the primary advantage of installing it systematically inside the structure. So a little bit about retaining walls and slopes. Of course, we know that often we see between the piles there's water coming out, trying to inject it and stop most of it. Maybe you have defect piles, water coming through. Maybe it's the wrong type of concrete, which is porous and the water can come through anyway. Maybe it's every second pile has been cast with a concrete which is not the same as the other and has problems. And these risks over the lifetime of the structure is significant. And so by just putting a concrete over this is often very risky and probably not enough, and will require later that repair works is being done. And if you do, as we saw here on the video, if you put the linker drain straight onto the leveled out surface and cover with concrete, shotcrete, it can actually prevent you from having these later costs and very time-consuming processes of repairing the structures. So, of course, when you have installed it, you'll have behind the inner lining, you'll have the water again being led to the base behind the lining, and you'll have the preventing of water coming in through cracking, and so on. So overall, you get a more robust solution with better durability and longer lifetime. Talking about the projects with the spray membrane, this is an example of a project from Canada where this was actually 2 tunnels with a wall in the middle. The wall was severely damaged and degraded, so they chose to take it out and put steel girders in to strengthen the whole tunnel. and then use shotcrete layers and a spray membrane. During construction, when they had put on the spray membrane, water came very quickly and gave them problems, so they couldn't continue, and they basically changed the design at this point. The designer changed the design to include the Dolenko drain. And after putting this in, they saw the issues. Putting the Dolenko drain in behind the shotcrete solved the issue. So after putting the smoothing layer on before the spray membrane, they had a dry surface and didn't have to do any remedial work, could put on the next shotcrete layer and finish the structure. And as maybe you can see here on the photo to the right, that it's made with the umbrella system. So we have kind of the jumps on the surface of the tunnel, and this was also covered by putting Dolenko drain in the angles there, so it can take the water on both surfaces. The modules are very flexible, so they can adapt to the surface of the structure. And at this point, I'd like to show you another little video where you can see the unevenness of the surfaces where it's possible to apply Dolenko drain. Just give me a second here. Where is it? Video this. And sorry, over here. Great. As you can see, the nail gun is battery-driven, very easy to hold handheld nail gun. And notice the unevenness of the surface here. Okay. Here's an example of another project where it is a combination of the top part is second piles, because it's soft soil, and the lower part is shotcrete directly onto rock, because it's hard rock. And what they did, they combined this in this shaft, and put shotcrete on the rocks, leveled out the second piles, put the Dolenko drain on the entire surface all the way, down to the arch. And later I'll talk a little bit about how to solve where the arch meets the tunnel, collecting water there. But in this way, you have a complete system of water draining the length of the shaft in different materials. And I'm going to show you I'm going to zoom in on the small detail here down to the left. And what I would like to illustrate here is that if you see the pink line next to the wall surface is extended 100 millimeter in past the slab, below the slab, and the pink line there, that is Dolenko drain. And this was a very simple and easy way to alleviate the water from the Dolenko drain modules into a stone layer beneath the slab. There's a different ways of doing this detail, and I'll get back to this also in the next few slides here. First, a repair job. This was a very old road tunnel that was closed. And it was closed because there was so much water pouring in through the ceiling. and the tunnel was repaired. First, they took out all the bad concrete, cleaned the reinforcement, put corrosion inhibitor on, and basically built up the layers again, including Dolenko drain. And after they finished, they also with spray membrane, and at the end there was no seeping seen whatsoever. And to the story goes also that above this, the reason there's so much water coming in is because above this there is a river, so there's plenty of water to stop. But it was absolutely dry after this. Here's another example. This is from Philadelphia, USA, and it's basically to illustrate that you can also, as you can see on the picture to the right, you can also just remove 10 centimeters of concrete, put the Dolenko drain in, and cover with 10 centimeters of concrete again. Then you basically stop the water from coming in through the inner lining, leading the water to the base behind it. Here's another example of spray membrane. In the Mumbai Metro, we didn't do the 33 kilometers, but the part we did with the Dolenko drain was done because they changed from a sheet membrane to a spray membrane. And since there is no systematic drainage available behind a spray membrane, then they found that Dolenko drain can do that. And you can see also here, it's also combined with line drains, which makes sense sometimes if you have a lot of water coming in. And like we discussed, or I mentioned this a little bit in the beginning, that sometimes you have some remedial work, and that could be one of them. And this is something that we can also help when you sit as an engineer with a project and you're not sure exactly how to use the Dolenko drain or what is the best way and what to do with remedial work and so on. We can give you the input of our experience of waterproofing and also how to optimal use the Dolenko drain in the structures. Here we have a project which is a railway station, underground station, also with second piles, shotcrete, and Dolenko drain. And finally, before showing you a few design drawings, this is a project from Switzerland. And this was a refurbishment, a repair. The tunnel that collapsed, you saw the picture in the beginning, the tunnel collapsed, and they rebuilt part of it and put the Dolenko drain in and covered with the shotcrete, put a drain at the bottom of the wall, and then basically cover with shotcrete, and that's it, and no more. And it has worked satisfactorily to the client. So finally, I have three design details for principles of some of the designs, and basically it describes what I have been talking about here. But the detail I'd like to show you is the detail in the middle, which is the bottom of the wall where you alleviate the water somehow. This is an example where you basically lead the water down out onto the top of the slab. And if you can notice here, let me just zoom in a little bit. Here we see the base of the wall, Dolenko drain mounted directly onto that, and then a geotextile, a strip of geotextile over the end of the modules and out onto the floor. And the reason we put this there is so that the shotcrete will not block the end of the modules. And then we recommend to stop the shotcrete at 20 millimeters above the floor, so the water can freely flow out onto the base and over to the drain. The next detail here is about the tunnel base, another way of alleviating the water at the bottom. And here we see the rock surface. We see the initial first shotcrete layer onto the rock. And then you see the Dolenko drain installed onto that. After that, you install the perforated pipe and put a geotextile strip over the end of the module and around the pipe, followed by covering with shotcrete and a spray membrane or sheet membrane, and finally finalize with shotcrete, or it could be cast concrete also. Finally, the simple version here is the alleviating of the water from the Dolenko drain modules into a perforated pipe only by covering with geotextile and shotcrete. And of course, if you want to do the other one or other solutions, again, depends on the situation, the individual project that you may have, and the individual presentation or the individual design.
Hey, thank you. Thank you very much for the very nice presentation. So now we invite the attendants to ask questions in the chat. We already have one. I'm gonna read it to you. So in zones of limestones and carbonaceous water, so hard water, it's possible to get clogging in the drains because of this concentration of carbonates, and how does this can be avoided?
Yes. I mentioned that a little bit during the presentation, that we have a system for cleaning out the strings. As I show that, I have a sample here of the model. You can see here the first of all the strings here, and the water alleviate to the sides. And this is what happens if you block it here. Water will rise a little bit and go to the next string and the next string and the next string. That's the first thing that happens. Since we have very little, we don't have a huge amount of water. You shouldn't think about this as a line drain where you have a lot of water coming through one string that you have to flush out regularly. This is not the way that the product is meant to be. You're not having a flushing water all the time. You stop the most of the water, and then you have locally you have seeping coming out. And then if this blocking happens, you have the alleviation to the side. Well, when that is said, of course, you could have a situation over many years where you have a few of the strings closing in an area. The first thing that will happen is that you'll also block the water from coming out in those areas. So you'll stop the water from coming from the structure into the strings. So that's the first thing that happens. And then if you have a serious situation where, let's say you have over the time you have the client can see that there's a problem with water coming in a region, then you can go in and scan the surface, identify the strings that are blocked, and then you can approach it different ways. You can either do the first thing, which I mentioned in the presentation here. You can drill in at an angle and route out the blockages mechanically, or with water, which you do is in line drain, normal line drain where you flush it out. Or you can also be more pragmatic. You can say, okay, I don't want to start breaking down anything. I just want to not have the water on the surface of this structure. You could, if you have space, you can actually just put new modules over that area inside and cover that with another 50 millimeter layer of shotcrete. So there's a number of ways you can approach this if this happens. But it's not something that we see really is an issue. But we have the availability of these different solutions to manage it.
Okay, so basically the primary shotcrete also is part of the system, because this is low permeable and this is containing let's say a high flux of water, and then all the seepage is the one that is let's say canalized through the drains, right?
Yes, the primary concrete shotcrete is a standard shotcrete. It's actually it is waterproof, but it cracks, right? So you will have some seeping. The question is how much volume do you have there? How violent is that seeping? If can you get your shotcrete onto it? Do you do some remedial work first so you have just a little bit of seeping here and there? That's the situation we normally see when we put the Lincoln drain on. And the photo you can see behind me here, that's actually a very, very good illustration of how the surface would look like with the seeping. And this seeping is absolutely no problem because it's minimal what it is compared to how much the drain can take. And so, and of course, I would also be happy to also contribute to if you're doing a tunnel and comment on the what to do before, how much to do before, what do we need, what can we recommend, can we just leave it as it is, you know? So there's a number of things you can do there. I think it would be too much to elaborate on all these remedial works here, but this is certainly possible.
Okay. So we have another questions, one from Alejandro Vélez, who is asking about the geometry of the drain. So this, what is the principle behind the design?
Well, the principle behind the design is now, this is just a small, you saw the module, what it looks like. This is just a part of a module this is to illustrate. So you can have it handheld, you can see exactly how it connects and so on. You can see here, this is how they connect sideways and so on. So, but basically the principle of this design of the strings like this is that they should cover the entire surface in a standardized way, so that any water that might seep out somewhere later, which we see so often over time, will be caught by the strings and alleviated to the base. That's the first principle of the design. Now, you could ask yourself, why this space? How much space should there be between these? How safe is it to take water if there's not, since there's nothing to take the water here? You can have a point here, say, okay, what if water coming out in a point here, where would it go? Right? And the first thing the water comes out here, it will go like this, down like this. If there's only a point, it's very unlikely that you have just a point. Typically, it's a crack, right? So the water will find the nearest string. This is what we see. And also the water will shift downwards and go to a string there. So just make a canal behind that secondary concrete. So it go down. It's not going to go through the concrete like this. You know, water finds the easiest way. So,
yeah,
so this is the.
Oh, sorry.
Go ahead. So that's the second principle of the design of this design of the this type of design. I don't know what to call it.
Yeah, because at the end, this is not exposed. This is covered by another layer of shotcrete. So basically, the water is going to try to find these canals because there is low pressure there. That water always want to go to the lower pressure zone, right?
Yes. If you have concrete like this over it, it's not, the water's never going to try to go like this. It'll also come in and then it'll go like this, or through a crack. But it's very interesting because with the background in waterproofing, you know, we know that water can find the weakest way, and it always will find the weakest way, and that's it's actually kind of a reverse principle of that we use for the design of the drain, that it will always find one of these strings because it's the weakest place to go to, right? And then I don't know if I should say more about this, but also I don't know if that has to do with the shape. I don't know if that answered your question, but also you have the flexibility of these modules, as we saw in the last video. You know, it's made with a very soft material, so it can actually accommodate the unevenness of the surface, and also the connections here are made so that they can vary like this, and the same on the sides. It can vary when you connect. Let me just hold them right here. So you can vary them also sideways here. Oh, that's better, like this. Accommodating to the surface, and then just nail it here. As you can see here, you have the nailing points are marked here, so you can actually see where to put the nails. And we used, as I said, we use 30mm nails and have all these nailing points available here.
Okay, perfect. I think this also answers another question from Leon Felipes, who doesn't have, it's not clear for him how does the system can drain the water if it's completely covered in shotcrete, but I think it was more or less explained in the same question.
Yeah, I guess it's because, you know, you have to think like you have the hollow strings here onto the surface, and water comes out through this surface somewhere and is caught by the strings, right? That's the principle.
Very good. So also Joaquin Gutierrez is asking where can he get the video of the Dolenco drain installation in the shaft with the second piles? If it's possible for him to get it.
Of course we can, if he sends us an email, we'll be happy to send. I showed you, I don't know if you saw the last email address that I put on the screen at the end of the presentation. If you didn't catch it, you can use our info or we can do that after also if you want, but you can send it to info at dolencodrain.com. And we'll definitely send you, and we'll send you some other information as well if you need that. And if you have any also specific design questions.
Hey, do you want me to copy paste your email?
Thank you.
The
Yes.
chat.
Thank you for that. Yes.
Okay, so there is the
ONOPKO. There's an O missing at the ONOPKO. So there's 3 O's in the name there in the.
Okay, so Alejandro Vélez is also asking about how this drainage can be clean, so maintenance of the drain.
Well, I think we talked about this a little bit, and one of the things now when you talk about cleaning, the effect of when you have the material we have chosen is very, very non-stick. The inside of this is the inside side here, where the water comes. This is a non-stick surface. It's like when you have a gas can and you go and buy gas and the gas station run out of gas. This is the same material, so it's very, very smooth here, so it doesn't stick to the surface, right? So it's very easy to flush it clean. And as I said before, you can also, if you have the heart blocking, you can route it out mechanically. But the flushing is done with the we didn't talk about that specifically in the presentation how you flush, but you drill a hole into the string above where the blockage is or where you want to flush from, and then you put a nipple in with a standard hookup for water hose and flush it like that. That's how you do the flushing.
Okay, another question from Juan Carlos Garcia. He's asking how this system works in conjunction with another system as long like horizontal drains or long perforation drains. I'm not sure if translating it correctly.
Is it like are we talking about the perforated pipe maybe?
Yeah, I
the bottom.
Think so, yeah.
At the bottom.
No, not at the bottom, but I think in conjunction with other type of drainage system. So
well, I would have to see which one we're talking about, because there is a number of products in the market and how we would connect with that. This is typically something that we answer in specific project detailed design cases where you would send the drawing, the detail to us, maybe just a sketch if you have a sketch of it, or if you have your actual drawings, and we can sign an NDA if this is necessary. And then we can comment on this, how best to do that, how to optimize that detail. I think that's the best answer I can give here, because I'm very careful about answering a question about a detail I hear like this, because do we agree are we on the same page there? So that's how I would do that. If I don't know if, or maybe the person who was asking maybe want to elaborate on the question.
there is a second part of the question that they are asking if this can substitute other type of system of like geosynthetics based system. Like he's mentioning one in particular, the NK drain. I don't know if you are familiar.
Yes,
so
I'm
if
familiar.
This is a substitution for that, or it can work in conjunction with that.
That's a very good question, and the answer is that in some applications it's a substitute. In other applications, they work together. Depends on the construction details, on the construction parts. Because we have used the Lenco drain on walls where Enkit drain has been in the invert, for example. So we combine those two and couple them together. This is possible. So it depends on which. We also have. Like I mentioned, the line drain, where you combine them. You put the line drain in and you put on specific places and put the Lenco drain on surfaces. We also have another system, which is we call it the dimple sheets. Where you have these like egg trays that you mount, you anchor them to the surface, and then you shotcrete over that. That's a different system, and we subsidize that. So that's instead of that system. So that I think that's what I can say now about we substitute. It's a standalone system, yes, but sometimes it's a good idea to combine.
Okay, and there is a related question from Juan Chacon about the comparison between this system and other based on geomembranes and geotextile, and it's about the cost. How does the cost compare between them?
Yes. Well, that's you cannot compare, the direct prices. The price of the product and the price of the design system you're getting is different. And this is one of the huge advantages of the Lenco drain, is that it changes the design so dramatically and positively that you have savings that are much higher than you don't want really to look at the direct cost of the product and the installation of it. It's not directly comparable, the different solutions. That's what we have seen in the comparisons we have done. We have one I can tell you about the one in I think that was actually the one in Colombia, I think, where they had like I think they saved 50%. It was about 50% time and 35% cost of changing to the system from a sheet membrane. That was from a sheet membrane. So those numbers we have just recently. So that's one way of comparing. And this is, of course, something you need to do in each application.
I can imagine that, for instance, in the design, if you are already considering a primary shotcrete layer, then I think that the system will be very competitive because you already have part of the system already in the design, right?
Yes, absolutely, yeah.
Okay, Pedro Condori is asking, I think you show an example of this in one of the slides, but he's asking if this can be applied directly into the rock before the shotcrete, with the objective of getting directly the water from the rock.
Yes. As I mentioned in the presentation there, that the way the Lenco drain works is that it is used on level surfaces, concrete surfaces. That's the primary thing, because it needs to be no more than 5 millimeters from the surface to be in function. So we don't risk that shotcrete goes in and close the strings, right? That's the first thing. The second thing is that you can use it. It's not going to be perfect as it is when it's on the surface like that. But we have an experience that if you use it directly onto the rock, you can be able to get the shotcrete to stick onto the surface. You can alleviate at least 80% of the water and be able to work. So in that way, yes, you can use it directly onto the rock. And I would be very happy to talk about that again, specifically if you have a specific situation where and discuss that. We can make separate online presentations and discussions on the individual projects.
Perfect. Thank you very much. There is another question from Joshua. He's asking, does this system replace the primary coating of shotcrete with metallic fibers?
If you the primary shotcrete,
the primary coating of shotcrete. I don't know if he's referring to a layer before applying the shotcrete.
Yeah, I have to be careful now that what I say about this, but for the shotcrete before Dolenko drain, it doesn't have to be waterproof. So if you are adding fibers to make it waterproof, you don't need them. If you're adding fibers to give strength, you still need them, right? And the shotcrete after Dolenko drain, you may use fibers in that you're not damaging Dolenko drain. This is often a question that we have: does it damage the drain when you use fibers in the second shotcrete, which goes over Dolenko drain? And it doesn't. And of course, that's a good way of making the secondary lining waterproof, which is what most people, when they design, you design the secondary lining to be waterproof in some way. Fibers, wire mesh, or crystalline waterproofing, spray membrane, sheet membrane, and so on.
Okay. I think we went through all the questions. And also Alejandro Valdez says thank you and excellent presentation. I think no, we don't have any other question. So I think we can finish the seminar now. Of course, not before. Thank you again, Johnny, for this very interesting presentation. I see a lot of interest because of the questions, and I'm sure people is going to be writing you if they have further questions.
You're very welcome, and thank you for this and very interesting questions. So this is always nice to hear some new angles on what we're doing. Thank you, thank you very much, everybody.
No, thank you, and all the attendants, please stay tuned. I think we have still some other presentations coming, so please stay tuned for the next one. Okay, bye everyone.
Bye.